Okay, this is a conversion of a lantern battery from lead acid to lithium ion. So there's the lantern. You can see it had a rechargeable battery in the bottom, which I have torn out. There's the case, which goes in here somehow. Goes in that way, yep. And the lid makes contact on the two springs down in there to power this. This was a 6-volt lead acid, and this is the battery that was originally in there, and it says 2.6 amp hours right there, 6 volts. And it had some circuitry which I've all tossed, but as lead acid batteries do, they get trashed. And I had an old laptop which had some other problems, which I scrapped out, and I got the cells out of it. I took the cells out and I put them through this LiPo, this 18650 optimized charger exerciser, and running this, it'll give you the capacity of each cell, and then you can feel it to see whether it's heating up. And so this was a laptop that only had probably about a 10 or 15 minute battery life, which is a little mysterious because the cells looked pretty good. So there's enough space in here to easily put 4, and with effort I could put 6, but as you can see from the numbers I wrote on here, this number is the number of amp hours, 1900. So this single cell is very close, probably when it was, well, this one, this high one, 2.04 amp hours, is very close to what the cell was. This is about roughly a 4-volt cell, 3.7 volt, but it lights up that light just fine at 3 volts. And so getting it as bright as possible isn't the goal. I don't really need to worry about getting 6 volts out of it. It runs fine on the 3 to 4 that these things produce. So if I pick 4 of these, so if you can read the numbers, these 4 are the 4 high ones, and then that one is just extra high, although it's not very much. It's got 100 milliamp hours more. And I wrote the resistance, this is in milliohms, so the high one here, 93, 126, so the high one has 125 milliohms, so you know, 0.1 ohms, whatever, however they measure that. 17. Yeah, so these other two are low, so I'm just going to leave those out as the low ones and put these together inside this space, probably like this, because it fits that way. I have a micro USB charger here, and it's one of the ones that has low voltage cutoff. So what that does is that you don't wire your load to the battery, you load it to this thing's cutoff circuit so that it will not ever deep discharge these cells, which is a nice feature. You want the light to go all the way dead, but it saves the battery. It doesn't deep discharge the battery, which lithium cells, they aren't happy with that either. So this saves that, and then the charger, of course, avoids overcharging. And then I'll be able to stick this through probably this little hole here and epoxy it in somehow so that we can charge it with micro USB. So that is the plan for this. And so I'm going to solder this into a pack and fit it into here. And then we'll restart the video at that point. Okay, so got my 4 best cells to fit in here. but I'm worried about these exposed contacts in here. So I want to put a little liner in here so that nothing could short out, and I can feed it through these wires through my current limited deep discharge protected charger. So I'm going to use some of this white plastic cutting board, which I'll cut to fit in there, to insulate the cells against these parts. And in this particular case, these contacts that go inside are exposed all the way to the inside, so potentially you could set this pack down and lay something across it, cause current to flow, and then you're going to depend upon the safety features of this board to protect it. And then, maybe have to replace that, or maybe cause a problem. So that's the next step, is to cut this to size. Okay, we're all wired together. Well, electrically anyway. I've got my 4 cells, my charger with the low battery cutoff, all connected. If I plug USB cable onto there, should get the right lights lighting up. Okay, so this says it's charging. Let's see what the voltage is. Charging versus not charging and all that. Let's see what we got. Okay. So let's see. The red and black are the battery. So we got. Okay, we have 4.1. Take the USB off. We expect it to drop a little bit because it's in charging mode. So we have 4, so it's charging. And let's look at the output of the low battery. Actually, I did that wrong. The output of the low battery part is the red and black, 4.1. And then the actual battery is the green and red. Let's see if I can get onto there easily. I'm going to get a couple probes here. Here we go. Let's poke those. This is the raw battery, 4.106, and then let's look at the regulated, this is protected one, 4.132 versus 4.10. So the battery is a little bit lower, which is mysterious, but it's all within error. Let's plug it into the lantern and see whether it goes. Okay, so let's get the lantern out here. The lantern is off. Let's take the USB off. So this is going to need to have some kind of silicone or foam or something packed around it so that it doesn't move, because I went all this effort to my piece of cutting board, flexible cutting board cut to insulate the cells. Let's plug this in. And okay, that is low and high. So that looks fine. Oh, let's check the voltage while it's running in high mode, because that's interesting. Okay. And I haven't done any of the messing around to see what the current draw is or anything like that. Remember, the original cell, which is sitting here somewhere, was 6 volts, 2.6 6 amp hours. We replaced it with about 6 amp hours, about almost 3 times the capacity. We've put protection on battery discharge. We have USB charging, making it probably easier to charge than 12 volts originally was. And so this should be better in many ways. Unfortunately, I had to buy a laptop in order to get the old discardable cells. Okay, so let's look at the battery side. If I can get in here. It's under load. Okay, raw battery voltage 3.9 volts. So it pulls the battery down a little bit. Let's plug the charger in and see what that does to the loaded. It should charge fine while it's loaded. Four volts. 3.9 again. Okay, so that all makes sense. And then this pops out. So we essentially now have a lithium portable light, lithium ion cell powered. So now we need to find a way to get this cap on there and still expose the USB. So there's a hole in there which I should probably use. Needs to be maybe made slightly bigger. Maybe you can't see this, but I'm just checking the size. I need to ream that out a little bit, and I think that's going to be it, just with a big lump of epoxy, because there's a good finger depth space, and then silicone this in so it doesn't move. So I'll make one little snippet at the end, maybe just a still picture so that I don't have to bother with video editing on this, showing it all put together. And it's actually lighter than the lead acid cell that had roughly a quarter of the capacity, 1/4 of the weight, and USB chargeable. So, you know, lead acid is not good. Lithium ion cells good in this so far in this application. And I should weigh this. Unfortunately, the scale is another one of these projects. I have a busted scale that needs to be torn apart, either fixed or made into parts, but I'd say 50% weight savings probably, and approximately 4 times the capacity. Let's do some more work and maybe we can continue the video. This is gluing up. So I've got the battery pack here, the USB charger, protection circuit, and the lid. I've got some 2-part glue here, not epoxy, but a pretty good glue for sticking pieces of plastic together. And another half hour or so, this will be set up enough to try to do the next level of assembly and testing. So we'll continue on from there. Okay, the glue has set up, so we're ready for the next step, which is more glue and closing it up, and another test, charging test, and so on. So the board is glued onto the little hole. Let's start with the charging test before I add a bunch more glue. And we've got a little glue sticking into the connector here, which Looks like it's going to come out pretty well. Okay. Okay, it's plugged in. It's charging. The little red light just happens to shine through one of the mounting holes there. And you can kind of see, you can see it on the camera there if I get close enough. So that's good enough to tell whether it's charging. The green light is right behind there on the board, so I'm going to assume that that's going to shine through when it charges. And I want to put a little more reinforcement on the board so it doesn't break loose once I glue it together, because it'll be hard to fix. So I got some of the very viscous epoxy that you can make a big bead with. This stuff, what do they call it? Quickwood. And I used Quickwood. I got Quickwood because that's all they had. It's the same thing as all the other similar epoxies. This is just colored like wood, and it's going to be covered up anyway, so it doesn't matter, and it's a little hard to get out of the tube. There we go. I think some of it. It's got a disc on the end of it. So I'll roll up a pile of this while we're paused, and then when I get it all ready to squish on, I'll start it up again. Okay, got it all glued together, top stuck on. I used silicone sealer, neutral cure, because it's electronics and I don't want to have acetic acid coming out. And I mounted that circuit board. This is useful info here. If I mounted the circuit board 90 degrees off for where I should have. So you can see I've got this connector in here at an angle because the cells are in here this way. Sorry, the cells are in here this way. And I put the board in there this way, so it hit the cells. I should have mounted it this way, so it would have slid in between and it could have been straight. So I ended up having to bend it over with the heat gun, and then put a whole bunch of this glue on there to try to hold it in place. And I have it plugged in here to verify that it really is still charging, because always make sure it's charging before you put glue on it. You can see the little red light there, maybe. If I get it focused just right, there we go. I can see it there. Tells me yes, it is charging. And the silicone glue is chosen because of the possibility of something going wrong, and the ability to cut silicone glue off is a lot better than stronger glues. And this isn't a high strength joint here. This is just a cover for a battery pack. So that's it, converting lead acid battery pack to lithium ion.